In combinatorics, in the study of counting specifically, there are two fundamental rules. Right? One of them is the multiplication rule. One of them is the addition rule. So we're going to talk about the multiplication rule first. And I've got an example here that illustrates how this process works. Right? So we have somebody and he's planning this trip and he's going to go from Tampa to Louisville. And he has two choices that he has to make. I really want to emphasize that point because a lot of the questions that we're going to be answering throughout the course of this chapter really come down to that fundamental question. What are the choices that I'm making? Right, so here he has two choices to make. He has to choose a plane flight and he has to choose a rental car. And what I want to know is what is the total possible number of itineraries that he has to choose from? All right, well, here's how I'm going to start analyzing this. All right, I'm going to say, look, his first choice is to choose the plane. All right, so I'm going to make a little tree diagram here. It's going to help me to organize what's going on with this. So first, he has flight 1, then he has flight 2, and then over here, he has, oh, sorry, let me try that again. Try to make it look a little more balanced. There we go. Over here, he has flight 3, right? Those are his three choices for the plane flight. Now, let's say he chooses flight 1, right? How many options does he have? How many choices does he have from here? Well, he has one choice, but that one choice has 4 options. He can pick 1, 2, 3, 4 cars, right? See 1, 2, 3, and 4. Right, well, how about if he picks flight 2? How many choices does he have? How many options does he have for his car choice here? Well, it's the same 4. Right? 1, 2, 3, and 4. 1, 2, 3, 4. There we go. And over here, if he picks the third flight, you get the idea by now. He has these same 4 choices. And now I know how many different selections he has altogether. Every end branch here represents a unique combination of plane flights and cars. So you just count along the bottom row here, and you see pretty quickly that he has a total of 12 possible itineraries. So if we take a step back, right, and kind of think about this a little more conceptually, he had 3 choices for this, 3 options for this first choice. And then going to the next level, because he had the same number of options for each of those 3 choices, right? The number of choices increased by a multiple of 4. Yeah, 3 times 4 is 12. And there you see the multiplication come into the process. So what I've done here is I've taken the conclusion that we saw in the previous slide and generalized it. All right, so let's say we have a task to complete and it requires k steps. As k would have been 2 in our previous example. And I know how many ways each of these steps can be done. The first step can be done m sub 1 ways, the second step n sub 2, and so on up to m sub k for the last step. Right, then the total number of ways I have that I can complete this particular task is just the product of the number of ways that I can do the individual steps. All right, so that's the multiplication rule. All right, let's look at some examples of how we can apply this. All right, I've got a practical example here for us to take a look at. Right, and what we're doing is we're making license plates. And I know that the number on the license plate is made up of 2 parts. The first part has 3 letters, and the second part has a 3-digit number. And I have this rule here that says no letter can be used more than once. The numbers, I don't care. The numbers can repeat, the letters can't, right? So ABC is okay, but ABB isn't because the B gets repeated. So my question is, how many possible license plate numbers are there? And this is, a very, very practical question. When you're designing something like this, you want to make sure that this is a really big number, because you don't know, how many millions of cars you're going to have to deal with over the course of, I don't know, decades or centuries even. Okay, so remember what I said earlier. Analyzing these counting questions kind of comes down to thinking about what are the choices that you have to make. Right? And the multiplication rule says that if I can assign a number to each of those choices, I can get the total number of outcomes by multiplying everything together. Right? So in this case, I have 3 choices that I have to make for each group for a total of 6. So I have to choose 3 letters for the first part. Then I have to choose 3 numbers for the second part. Right, how many options do I have for each of these choices? Well, looking at the letters, for that first letter, I have 26 different letters in the English alphabet to choose from. So I've got 26 choices here. Now, for the second one, I don't have that many, because whatever letter I chose to go in that first spot, I can't reuse it. I don't know what that letter is, and it doesn't really matter. Right? All I need to know is how that narrows my options going forward. Right? So for this second choice, I only have 25 letters to choose from. Then for the third choice, now you're looking at that original 26, right? And now I have taken 2 letters out. The letters from my first 2 choices are both off limits. So for this last space, I only have 24. All right, that's the letter part, right? How about the number part? Well, the number part, remember, we are allowed to repeat here. So I have 10 choices for this first one, 0 through 9, 10 choices here, and 10 choices here. Okay, now I know how many individual choices I have to make. According to the multiplication rule, the total number of possible outcomes here is just equal to the product of all 6 of these numbers. Right, so now you get your calculator out. Right, this comes out to 15,600,000. Put some commas in there, make it easy to read. 15.6 million. Right, there are 15.6 million license plates that we can make using this particular set of rules. So here we've got one that's a little more complicated. We're talking about North American phone numbers. Right? Phone numbers are made up of 3 groups of digits. Right? You've got the area code. You've got this part. These other parts have names. That's called the prefix. That's called the line number. Everybody knows the area code, maybe not the other 2. And there are some rules, right, for the numbers we can pick for each of these 3 sections. All right. So ultimately, I know what I want to do here, right? I have 10 choices that I have to make. I have to pick 1 digit to go in each of the 10 places in that phone number. So I'm going to start off the same way I did on the last one, right? I'm going to do 1, 2, 3. There's the area code. 4, 5, 6. That's the prefix. 7, 8, 9, 10. That's the line number. Okay. Now, we've got rules to follow, right? The first group of numbers, that's the area code. It can't start with a 0 or a 1. All right, so how many choices does that leave me with? Well, that means 2 up through 10, right? That's 8 digits I can put there. And how about the second one? Well, now for the second and third digits, the last 2 of the area code, anything goes. I can put anything I want there. So these can be any of the 10 numbers from 10 digits from 0 to 9. Okay, the second group, the prefix, this works the same way, right? It really is the same rule. It can't start with a 0 or a 1. So this is also going to have 8 choices for the first digit and 10 choices for the remaining 2. And the third group, anything goes. I can put anything I want in here. right? So these are going to be 10, 10, 10, and 10. Excellent. Now I know what my options are for each of the 10 choices that I have to make. And now we bring in that multiplication rule, and we multiply all of these together, and we'll get the total possible number of phone numbers. Right, well, 8 times 8, that's 64. And how many 10s are there? 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to follow this with 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. And again, just for readability, if we get some commas in here, there you go. 6,400,000,000 possible phone numbers using this particular scheme. All right, so that's the multiplication rule in a nutshell. In the next lecture, we're going to talk about the other rule I mentioned earlier, the addition rule. And the addition rule is going to seem a little obvious, right? But it's one of those things we really need to have in our toolbox, because one big limitation of this multiplication rule is you have to know how many choices you're making, right? In the first example, I knew I had to make 6 choices. In the second example, I knew I had to make 10. Well, what if you don't know that? Or what if you don't know that? For example, an example we're going to look at in that lecture is, what if you have a phone and you can install anywhere between 3 to 5 different applications on it? We'll know how many applications we have to choose from. The problem is we don't know how many choices we have to make. Are we going to make 3 choices? Are we going to make 4 choices? Or are we going to make 5? Right? That's the kind of scenario where the addition rule is going to come in useful.